So exercise 98, page 224, question number 3. I've drawn it out. I've tried to make sure that side FE is a bit shorter than side DE, and then putting the angle F in as 26 degrees, that sort of makes it obvious that angle E is greater than 90 degrees, but that can be an issue, as is mentioned in one or two of the work problems. I think work problem number 3, and also in the next question we're going to have a look at, or I'll have a look at in this exercise. So what we're asked to do in this case is find the missing side little e and also the missing angles. So the process is, well, we can use the sine rule because I know one angle and the side opposite it. So I know one of the ratios, and this other piece of information means that I can then use that to find the angle opposite that. So I can use the sine rule to find angle D. Once I've got angle D, I can then find angle E because the angles in the triangle add up to 180. And then when I've got angle E, I can use the sine rule again to find side E. So that's the procedure. So you might want to have a go at it, but I'll run through the solution underneath. So the sine rule is going to come in, and as we're after using that to find angle D, I'm going to write the ratio that way up. Sine D over the side, which is 17, equals sine of the angle we know, which is 26 degrees, over the side that we know, which is opposite that, which is 22. So now I'm going to rearrange this little equation to find D. So multiplying both sides by 17, sine D equals sine 26 times 17 all over 22. I can think of it as a fraction like that. I can write it as sine 26 over 22 times 17, or sine 26 times 17 divided by 22. The same answer. I'm after angle D, so I need to find the inverse sine of this ratio, which is sine 26 times 17 over 22. So that's what I'm going to key into the calculator. Always try and do it in one hit on the calculator if you can, because that means that you can hold the accuracy all the way through the calculation. So to do this, I would use the inverse sine button on the calculator, and then I'd hit the fraction button on the calculator. So I can put sine 26 times 17 on the top and 22 underneath, not forgetting to close the bracket after the 26, and also making sure the calculator is in degrees. And then I should get the answer, which turns out to be 19.8 degrees. The only thing we need to do now is to convert that to minutes. And so if you think about this 0.8 of a degree is 8/10 of a degree. And that's got to be in minutes. So what's that in minutes? It's something over 60, because the degree is divided into 60 minutes. So now to get x, I've just multiplied both sides by 60. So in other words, to convert an angle from a decimal into minutes, I just multiplied by 60. So it's 0.8 times by 60 will give me the fraction of the degree in minutes. And that equals 48 minutes. So D equals 19 degrees 48 minutes. So now I've got angle D, I can find the other angle because they all have to add up to 180. And once I've got angle E, I can then use the sine rule again to find side little e. And that procedure is outlined in my solution to question number 2.